Education is the key to a bright future. Empowermefirst.college.
This video will talk about the LCM and GCF in real life. It will be a chance for you to practice LCM and GCF and at the same time to understand how they can be used in real life situations. In the first example, we are talking about a girl. Sarah goes jogging every 6 days, while her friend Amy goes jogging every 8 days. So here we have Sarah. Every 6 days she goes jogging, and Amy every 8 days. That means Sarah goes jogging 6 days, 12 days, 18 days, 24 days, 30 days, 36, and so on. Amy goes jogging every 8 days, 16 days, 24 days, 32 days, 40 days, and so on again. They both jogged together on the first of the month. That means there was an initial point where they both started from. We want to know after how many days will they jog together again. So I see that Sarah 6, 12, 18, 24, 30, 36, and so on. This is 6, 12, 18, 24, 30, 36. However, Amy goes every 8, somehow here 16, 24, 32, and so on. Before we continue, we can easily see that they went together again at the 24th. This is simply the number that they will uh, take to start jogging again together. That means after 24 days, Sarah and Amy both will be jogging again together. It was clear that I was doing multiples 6 times 1, 6 times 2, 6 times 3, 8 times 1, 8 times 2, and 8 times 3, and so on. That's why I was finding the LCM of 6 and 8, which was 24. If you want to use prime factorization to find this LCM, you can do 6 as 2 times 3, there's no more. 8 is uh, 2 times 4 and then 2 times 2. So I am going to get 2 times 3 and 2 power 3. The common will be 2 power 3 times 3, which is 8 times 3. That means it will be 24. Now, part B. A farmer has two lengths of wire, one is 24 meters long and the other is 36 meters long. He wants to cut both wires into smaller pieces of equal length without any leftover wire. What is the longest length he can cut the pieces? Whenever you see a word problem of that form, that means a word problem, it gives you a set of numbers and you are trying to split these numbers into equal pieces. Directly remember that this problem is talking about the GCF. And the tests will be very similar to this thing, not more different. So I understood immediately that I need the GCF of 24 and 36. How? I want to cut the 24 and 36 into pieces, and at the same time I want to get the longest length I can cut these pieces into. So I am thinking about a greatest piece of numbers. That's why I'm talking about a GCF. After these two problems, you can understand now that most of the time, if you are talking about the problems that will talk about time, that means when you repeat time and then you want things to start again, remember that this will be directly LCM, like the first example. While if you have pieces that you're going to cut into the largest piece, you are going to talk about GCF as here. I will use prime factorization to find the GCF. 36, I'll write it 6 times 6, 2 times 3, and 2 times 3. 24 is 3 times 8, then 8 is 2 times 4, and 4 is 2 times 2. Now, I write like this: 36 equals 2 power 2 times 3 power 2. How did I do that? I have 1, 2, two twos. That's why I wrote 2 power 2. I have 1, 2, two threes. That's why I wrote 3 power 2. Next, 24. 24 is equal to 2 power 3 times 3 because I see that 2 is repeated 3 times and 3 is repeated 1 time. To find the GCF, I will take all the commons, only commons, which are 2 and 3, both are commons, but now with lowest powers. So I have here 3 power 1. That's why I will take power 1. Then my answer is 4 times 3 following the order of operation, which is 12. What does this mean? This means the longest length he can cut the pieces to ensure that each piece is the same length for both wires is 12. How can I understand this with uh, pictures? Let's say I give you figures. Look at what I'm going to do now. The first one was 36 and the second one was 24. So I'm going to cut them into pieces. Let's say this is the 36 and this is the 24, for example. Here I can cut the 24 into 12s and 36 into 12s also. I can cut them also into something different, which means definitely this will be 24, what I mean. I can cut them into 6. 6 here, 18, 24, 30, and then 36. So that's 18, that's 6, starting from 0. So you see that you can cut them equally into 6. You can cut them equally into 3s if you want. So 3, 6, 9, 12, 15, 18, 21, 24, 27 here and 33 here. I can cut them into, let's say, what else I have? Fours. 3, 4, 8, 12, 16, 20, somewhere here, 24, and so on. So I see that the largest piece in which you can cut them is the 12 because this you will cut it into 3 pieces and this you will cut it into 2 pieces. That's the longest piece. Any other piece you will cut them equally to, it will be less than, shorter than 12. That's why 12 is the greatest common factor of 24 and 36.